Hey folks, this is Ben from InstaCluster and welcome to the next episode of InstaBlinks. And with me today, we have the very captivating Chris Carter, who is our product lead for Postgres at InstaCluster. Chris, thanks for joining, mate.
No worries. Thanks for having me.
So before we get started, would you be able to just give me a bit of background about your past experience and your role at InstaCluster?
Yeah, sure. So I joined InstaCluster as an engineer just in the depths of COVID, worked my way up to being a team lead in our billing and reporting team, and then got moved into product management where I continue to lead the billing and reporting team, but also our Postgres product for our customers.
Awesome. So today we're here to talk about Azure NetApp Files and Postgres, right? So I know what one of those things is. Can you tell me a little bit more about what is Azure NetApp Files?
Yeah, absolutely. So Azure NetApp Files is a product sold by Azure, sold by Microsoft, but it is at the hardware level a NetApp storage system within the Azure cloud servers. So you're getting all the great features you love out of the NetApp on-prem stuff that you may be used to, but you can now access it in the cloud. So it's much faster, it's the snapshotting technology, and it's much more scalable than a typical sort of cloud dumb hard drive.
So it's got all those smart, I guess maybe if you're able to share a little bit more either under the covers or that kind of thing, but how is it different from like either, a local disk that might be running on my desktop here behind me or an Azure premium disk that you might attach to a VM in the cloud to run your own database? How's it different from some of the things we're used to?
Certainly. So, I mean, it's network storage and it gets provisioned in a pool, sort of like a SAN you might be used to if you've got your on-prem data center that you're maybe trying to migrate off of. So you can provision, you can scale it up, you can scale it down, you can sort of divvy it up into different chunks and send them to different workloads as you want, and it's all accessed over the network. So it does mean you have to set up your own network in order to talk to it. It's not just attached directly into the instance, but it gives you a lot of that flexibility in terms of putting your data everywhere across all your workloads.
So based on the little bit of reading that I've done, NetApp have sprinkled, a little bit of secret performance dust on this. What are the kind of the key performance benefits that you get when you run something like Postgres on top of ANF?
So the good thing about ANF is you can choose your IOPs independent of your storage. Generally, if you're using sort of a standard premium storage on Azure or the equivalent on the other cloud providers, you're just limited on IOPs based on how much storage you pay for. So sometimes this means customers who only need a 1 terabyte hard drive, they're like, we'll pay for 20 terabytes anyway, just so that we can get the speed we need. On Azure NetApp Files, you can select that just as a drag and drop within the Azure console, and that gives you the speed that you might be used to. So NetApp brought this to the cloud because some of their customers were saying, we can't move to the cloud because it's not fast enough. We cannot support our workload on cloud-based storage, which is how NetApp got their products into Azure with Microsoft. With this, you can. So on Postgres specifically, which is where I've obviously done the bulk of my work with ANF, we're seeing up to a 4x increase, or like 3.9x increase.
That's massive.
Yeah, 4 times faster on read-only performance and like 2.5 times faster in read-write.
Look, obviously the proof is kind of in the pudding, and I guess, folk have got to go give it a whirl on their own workload. And also the ability to kind of tune your IOPs to your storage. That's a huge benefit from the cloud, right? Is being able to scale kind of the performance and then the storage side independently, which is pretty huge. So obviously this all sounds too good to be true. What are the trade-offs that we've got to think about versus other disk types that people might be used to using?
There's 2 trade-offs. I mean, it's slightly more expensive storage. It's not drastic when you look at the price of a whole managed Postgres server, but it is terabyte for terabyte a more expensive product to get these features. And on the technical level, it is a decent amount more work, I would say, to set it up. You've got to set up private network so that your boxes can communicate with their disk over network rather than just saying, hey, Azure, I want this connected. The good thing, of course, if you want to use an InstaCluster Postgres server, is like we've done all that. We spent 9 months setting this up for you. So it is no different on the InstaCluster console. If you want to use Azure Premium Disk or Azure NetApp Files, they are just as easy as each other. There's no difference from the InstaCluster console.
Right. But I imagine maybe the per terabyte's a little bit more expensive, but surely the cost implications here shows that you make it back on the fact that it's way more performant. Right?
Easily. If your metric is sort of dollars per transaction per second, which is a metric that I've made up, it's definitely way cheaper. Like if we're talking I think we're talking like 10 to 20% more expensive for that 400% increase in speed. So you can do the maths on that, and it's much cheaper for the speed that you get.
Yeah, I mean, it's funny, like that dollar per read write of gigabytes. So like that's a real metric that a lot of like engineers have to use on a daily basis, right?
Yeah,
Because
it's
it
important.
represents kind of the density of the reads and writes you get for your storage, right? Which drives a lot of cost, particularly in the cloud, right? You look at that's the case with other products like, DynamoDB in AWS, right? That's a very real bit of math that people have to do. So I guess just to dig a little bit deeper, is there anything that Postgres needs to do to be aware of ANF, or how does it kind of that couple? How does it work together? Is there much that needs to happen there?
So on a basic level, it's the network to set up the connection to the hard drive, and that super duper speed. We can do some even cooler things, which are in our roadmap being worked on right now. So ANF offers this snapshotting feature, so you can sort of copy a whole drive instantly. Basically, they can just fork data and make two replicas, and to the machines it looks like they've got two copies of the data and they can read and write completely independently. In the background, ANF, I assume, is churning away, actually physically replicating that it has to, but you see it as within a minute you've got a new copy of your data. So to get Postgres to play nicely with that, we do have to sort of tell Postgres when these snapshots are being taken so that we can be at a logical, consistent point if we want to restore that. And this is going to unlock some cool things on backups, like you'll be able to back up terabytes of information within seconds for a local backup, and you'll be able to split your database. So this is a use case I love because I used to be a data scientist. So if you have your data scientists and they're like, oh, can we just like play with the production database? You're going to say, no, data scientists are going to ruin your production database. With ANF, you can just fork it and sort of just as long as creating a new Postgres server on Instacluster, that's 10 to 15 minutes. And then your data scientists have an up-to-date live copy that's only 10 or 15 minutes old, and they can play with it and they can run huge queries that are going to crash the server, and they can accidentally drop tables because they're not thinking very much, and it's all completely isolated from your production server. So nothing really goes wrong. They've just, they've got a play copy of their data. So I reckon that one's really cool. I'm looking forward to delivering that hopefully next quarter.
That's going to be massive. That's awesome. And I mean, combined with the performance increase and, some of the cost savings you can drive, I'm pretty excited to see what people get up to with the new Postgres on ANF by Instacluster, I guess. How can people get started?
Yeah, absolutely. It's fully in general availability. All you need to do is log into instacluster.com, sign up for an account, and choose Postgres, choose Azure. You can't run Azure NetApp Files on AWS, obviously. So once you go through that, it just looks like a node size. We put a little bold because it was got lost in the noise sometimes. But you look at one of those nice bold node sizes, and you're ready to go.
Awesome. Thanks again, as always, Chris. And as you said, please go check it out on instacluster.com, give it a test, and I'm sure you'll see those 3x and above performance promises hold up.
And if you do, let us know, because I'd love to get some more data from my performance testing.
Awesome. All right. Thanks, Chris. Cheers, mate.
Cheers.